This video is on significant figures in calculations and how we round numbers appropriately when we're either adding and subtracting or when we're multiplying and dividing. So first we're going to talk about how we deal with significant figures when we are performing either addition or subtraction, okay? And so the rule, and this is a hard rule to put into words, so I'm going to do my best and then I will show you an example. So, okay, when you're adding and subtracting, this is what you have to deal with when looking at your answer. So the answer to your addition or subtraction problem must contain the same number of decimal places as the smallest number of decimal places in the set of numbers. This is super wordy. I always have trouble wording that. So it says that the answer must contain the smallest number of decimal places as the smallest number of decimal places in the set of numbers. So what does that mean? So if I have this practice problem that says I want to add these two numbers together, so what I'm going to look at is the, first let's just do the math. So just like normal, we would add these two numbers. And I probably don't need a calculator, but I'm going to use one. Plus 8.1768. Okay, so if this was math class, your calculator would give you this. And you would either leave that completely written like that, or you would say, where do I round? And so this finally answers that question. So going back to my rule about smallest number of decimal places, so what I want to look at is that this number contains 3 decimal places, while this number contains 4. And so let me stay in that color. So since I have 3 decimal places and 4 decimal places, my rule says the answer can only have the smallest number. So that means my answer can only have 3 decimal places to match this one. Okay, so that means I am interested in keeping these 3 decimal places, and then of course I would ask myself, does the 8 out here round this 8? And the answer is yes. So I would report my answer as 12.829 in this case. Notice the 3 decimal places matches the 3 decimal places. Okay, so that's the rule if you're adding or if you're subtracting. It's all about smallest number of decimal places. Now, when you're multiplying and dividing, that rule is different. And so we have to do a different rule. And the multiplication and division rule has nothing to do with decimal places. It has everything to do with sig figs. So it's the same idea that the answer must contain the same number of sig figs as the smallest number of sig figs in the set of numbers. Okay, so this time it's the same wording, but it's the fact that we're looking at sig figs now and we don't care about decimal places. So in this example, I'm multiplying these two numbers, so I want to think about how many sig figs are in each one. So 40.25 has 4 sig figs, and 2.34 has 3 sig figs. So this rule says that my answer will only be allowed to have 3 sig figs based on the fact that that's the smallest number. So I'm going to go ahead and do my math like normal. And my calculator tells me the answer is 94.185. Okay, so if that was in math class, you might be okay with leaving that as is, but not anymore in our class because we're always thinking about rounding correctly to sig figs. So this case, I want to keep only 3 sig figs to match the smallest number. So that means I'm interested in keeping these 3. And then, of course, I just ask myself, does that 8 do anything to the 1? And the answer is yes. So I would report the answer to that problem as 94.2. Okay, so just a quick clarification. When you're adding and subtracting, you're looking at, does my answer have the same number of decimal places as the smallest number of decimal places? And when you're multiplying and dividing, it's sig figs. It's not decimal places. So that's the only thing you have to remember. So let's do some practice, and these should be on your worksheet, and we'll just do them together to make sure we have an understanding of this. All right, so the first one wanted us to add these 3 numbers together. So that is the easy part. So when I add them all together, I get 126.8 is what my calculator tells me. We're adding, so the rule is decimal places. So I have 2 decimal places, I have 1 decimal place, and I have 2 decimal places, so my answer can only have 1. And in fact, it already does. Okay, so sometimes you get lucky and you don't have to do any rounding, or you don't have to drop any decimal places or sig figs off, because in this case, what the calculator told us was correct in terms of the number of decimal places. All right, and the second one is in scientific notation. So for our purposes, I'm just going to take these numbers out of scientific notation. So 6.2 times 10 to the second is 620. And then 5.34 times 10 to the second is 534. So I'm just adding those 2 numbers together. So if I add those 2, I should get, let's see, 1154. Okay, now this one's a little bit interesting, and it's why I included it on here. Neither of these numbers have a decimal point, meaning the smallest place value is the ones place, okay? So I have a digit in the ones place, I have a digit in the ones place, which means my number has to also have a digit in the ones place. So again, in this case, I don't need to round or add any decimal places or remove any decimal places because it already matches. All right, the third one said, find the total mass of these 3 masses. So of course I'm going to add those 3 numbers. So I'm still thinking about decimal places. And when I add those 3, I get 23.842. But I have to ask myself, can I keep all of those decimal places? So this number has 1 decimal place, this one has 2, and this one has 3. So of course, it's this guy who's going to limit. So I can only have 1. The 4 does not round the 8 up, so I'm going to report my answer as 23.8. Okay. So those first 3 were all about decimal places because we were adding. And these next 3, I had to skip 4. So these next 3 are multiplying or division. So now I'm going to switch my thought process, and I'm only thinking about how many sig figs are in these numbers. So number 5 wanted me to calculate the volume of a cube, right? And hopefully you know that volume is length times width times height. So we're multiplying these 3 numbers together. And my calculator gives me a real long number this time, 17.5134333. Okay, we know we're not going to be able to keep all those. So again, this time it's about sig figs because we multiplied. It has nothing to do with decimal places. So I'm thinking about how many sig figs are in the number 7.55. There are 3. How many sig figs are in the number 0.98? There are 2. And then sig figs in 2.367, of course, there are 4. So my final answer can only have 2 sig figs. So I'm interested in these. And of course, I ask, will the 5 round this up? And the answer is yes. So I'm going to report my answer as 18 in this case. Let's talk about unit for just a second. If I found the volume by taking meter times meter times meter, my unit would be meter cubed. So I haven't been paying attention to units because I've been kind of being lazy in this video, but that's a good example of carrying the unit through my problem. Number 6 is a very similar problem. It says calculate the volume of a warehouse that has these dimensions. So again, volume length times width times height. I'm going to multiply these 3 numbers together. And I get a huge number, 1,316.224. I'm multiplying. It's all about sig figs. So this number has 3, this number has 3, and this number has 2, which means my final answer can only have 2 sig figs. I'm interested in keeping these 2. The 1 does not round the 3. So there may be some students who give the answer as 13. Okay, but 13 and 1,316 are very different numbers. So this is one of those cases where you have to add in those zeros for placeholders and to keep the value of the measurement, although it doesn't change the sig figs, because remember, those are trailing zeros, and with no decimal, they're not significant. So in this case, as 2 sig figs, the number 13, or the number 1,316 is going to be 1,300. Again, it would be meter cubed, because I took meter times meter times meter. All right, and the very last one is a division problem, still sig figs. So I'm going to take these out just to make it easier to put into my calculator. 1, 2, 3, yep. Okay, so just go ahead and divide these. And I get a very small number. Wonder, this is an interesting one because I don't know, depending on what calculator you're using, 1, 2, 3, 4, 5, 6. Your calculator may be rounding this number off early. I'm not sure. Might be something we have to come back and talk about later. But if you have a calculator that carries numbers out decently far, or if you're on your phone, you get a number that looks something like this. It even keeps going. So again, talking about sig figs in this case, this number has 3 sig figs and 2 sig figs. So I am limited to only 2 sig figs in my final answer, which would be these. The 5 would round the 6 to a 7. So you could either report this as 0.0000037, or my preference would be scientific notation. Let's see, what is that? 1, 2, 3, 4, 5, 6, 7. Okay, so that is your kind of intro to how we deal with sig figs when we are performing calculations. The big bottom line, or big idea, I guess, to keep in mind is that if you're adding and subtracting, it's all about decimal places, but if you're multiplying and dividing, it's all about